on the website afterwards, and as you've registered, you'll get notification of that as well. Okay, so right now we're looking at our injury statistics, and the injury statistics report that came out from WSIB for 2015, when you took into account all of the upper extremities, it pretty much equated to about 21% of all our claims are hand and upper limb extremity based. So when we're looking at, whether it be finger, thumb, carpal tunnel, forearm, elbow, all of those things are going to be impacted by improper tool selection. 21% of the claims is actually quite high. So trying to get some of those down is definitely going to be an improvement, obviously, to your health and safety program and your injury statistics. Question is how to do that. So what we're going to be talking about today is when we're selecting parameters, how are we selecting the right ones? Is anyone hearing the kind of echo or background talking right now? No? Yes, okay. Okay. Not quite sure how to stop that. It's not me talking, so.
Is it me?
Yes, it is, Jen.
Okay.
Perfect. Okay, so there we go. Sorry, that was just Jennifer, one of the other owners. Okay, so the question is are your tools ergonomic? Are you muted yet, Jen?
Sorry?
You're still not muted. There she go. Okay, so the question we'll often get is, are these ergonomic hand tools? And if you've ever been shopping at any Home Hardware, Home Depot, Rona's, Lowe's, the word ergonomics is a huge marketing strategy for a lot of our tool manufacturers. The question is, what are they saying is ergonomic? I've seen the color of the tool be the really only thing that's different from the standard tool that they're selling without the branding ergonomic, and it's just a different color, or maybe it has a slightly different grip, but it doesn't necessarily mean that that makes the tool ergonomic. There are several parameters that we need to be meeting in order to make sure that we actually do have an ergonomic tool, and some of them are hard parameters that are, we can physically measure, and some of them are more going to take a little bit more assessment or involvement on our part to make sure that, we are getting the right tool for the right job. And of course, just like ergonomics, it's about fitting the tool in this case to the work instead of fitting the worker, or fitting the work to the worker. So we're looking at the same tools. We've asked the question, are these tools ergonomic? So as I said, the answer is really not that simple. There are ergonomic factors that have been built in, and there's other issues that aren't. So for the function of these tools definitely leads to their ergonomic kind of component. So the hammer that we're seeing here, it is counterbalanced in a way that it's going to be used to actually aid in the task and the function that you're doing. So that's an ergonomic point. The hammer, the handle of that hammer, you can see it's got a bit more of a gripped handle. That's going to be added into your ergonomic check. The pliers, obviously, they offer a pinch point. The wrench has the adjustability of the opening of the head of it. All ergonomic points, but some of where we're not seeing some of the ergonomic is, for instance, the pliers are a manual mechanism for the open and close. Ideally, if we were looking at ergonomics at its best, that would be a spring mechanism that we could basically, it would self-open. We would just have to work on the closing. So that's reducing our repetition by half. We have the wrench handle, not contoured at all, slim, narrow. If you're going to be holding that for long periods of time, specifically if you're going to be exerting force, which you are because that's the function of the tool, that is not going to be a comfortable grip. It may slip if your hands are wet or sweaty. So there's lots of different things to be looking at your tools to make sure that are we getting the best tool. ergonomics does not necessarily mean a higher price point. The wrench on the right is not going to cost any more than a wrench with a padded grip, or there's maybe really low cost options that you could be doing in-house that can take the wrenches that you have or the tools that we are currently using that maybe don't offer the most quote-unquote ergonomic function, and make it better for us, make it better for our employees, make it better for our hands and forearms, and in the end, reduce some of the discomfort or injuries that we may be seeing creeping in there. So the 4 steps that we're kind of going to look at before as soon as we start talking, okay, well, let's get a tool to do it, we need to understand 4 things. We want to know, first off, what is it we're asking the tool to do? If we have a really bad idea, oh, we just need to strike this in, we don't need a sledgehammer for this. So to just say, oh, we need a hammer, that's not enough information. We really need to understand what the job or the task is and what purpose the tool is going to do. What are you wanting it to do? Is it just to secure a screw? I'm hoping it's not. I'm hoping it goes on to, a little bit more on the worker side and is going to allow a better fit, a better comfort, more comfort, and looks at both of those sides, both the function as well as the operator or the employee. So answer that question first. What's the purpose and what's the task that it's going to be doing? Then we want to know the workstation. What are some of the expectations? Is this station going to be standing? Is it going to be working? Is it going to be mounted, or are we going to be using this tool on a vertical surface versus a horizontal surface? The working height of the task or the job that's being done is also going to play into whether or not you have the best tool for the job. If you have a really high working station because it's a precision type task, then you want to make sure that your tools are not overly long or overly cumbersome, because you're going to be working with the upper extremity muscles, your shoulders, your upper back, and we don't have a lot of weight capacity in those muscles. So we know those tools need to be really light. We need to make sure that they're not going to be overly large, increasing our working height even further. Some of those things are kind of what we're going to be talking about. Understanding the tool itself. Are we looking for a tool that's going to be doing something powerful, something torque, striking, or are we looking at something fine motor, something precision-based? Is there a chance to take a manual task, making it more automated? Because if we can automate it with a power tool, then that's great. However, for those of you that have heavy tool use in your industry, you know that automated or power tools come with their own kind of set of woes. So yes, if we can put a power tool versus a manual tool, usually that will help with some of our issues, but it may not solve, it actually may create some. So making sure that when we answer that question, yes, we want to go with a power tool, that we're really sure that that's the right answer. And then we look at the selection of the ergonomic tool and really looking at some of the guidelines that we'll be discussing about in a few moments. So our things to consider: manual versus power. We want to consider the weight of the tool. We want to consider definitely the handle design, because that's really the interface. That's what we're connected with. That's what we're in contact with. And making sure that that is actually giving us the best fit is going to make sure that we're going to have the most comfort as well as the least chance of injury. The materials of the tool. Is the material of the tool going to be aiding the function, or is it going to be hindering the function? Any vibration that might be created, whether that is, an impact or striking type impact, which is, such as a hammer, you're still going to get a vibration from that, or whether it's going to be something kind of lower frequency but more continuous, such as a power tool. Vibration is one of those things that, as far as our ergonomic risk factors go, vibration stands pretty high on that list. It can cause us a lot of problems. So any kind of vibration, we want to make sure that there's some kind of dampening force around that so that we're not experiencing that on the body. And then looking at the work surface. There's been numerous times where we see, as ergonomists going into various workplaces, the tool's the right tool, the task is just fine, but the fall of the whole system kind of comes with the work surface, whether it be the height or the angle or some of the other parameters that kind of go in there, or even the material of the work surface. If you're trying to screw something down and you've got a really slippery work surface, or you're working on roller conveyors or that type of thing, well, that's going to only add extra muscular force, decrease your efficiency and your productivity, because you're going to be fighting to keep that object stable while you're trying to work on it. So your work surface is definitely one that I would say may not get the attention it often deserves. You spend a lot of time either on one or the other. You're either putting a lot of focus on your work surfaces and the task, or you're putting focus on the tool and the task, but we haven't really, very few times do we see it where all three are being handled appropriately. So we have several categories of tools, which is the first thing we want to ask that question. So do we know the job? Are we aware of the task? Do we know the purpose of the tool? That's the first question. So are we using a cut, a pinch, a grip tool? Are we using a striking tool or a struck against tool? Are we using some kind of driving tool? So all of these will start to narrow your playing field on what your choices and your options are as to which is going to be the best one. The price points on any of these tools are going to be relatively the same. They're not really, you're not going to be looking at a huge wide range. So as long as you're looking at good quality tools to begin with. But so that should be a decision point to such a high degree, specifically with your manual tools. But we want to then try and figure out, well, which ones are we liking better and why are we liking them better? It hopefully isn't because, well, I like it because it's orange and, or it's pink, and actually has some good ergonomic parameters behind it, and that's why we're choosing it. Okay, manual versus power. I will say that there are lots of times where, power tools just are not an option, whether it's because the task is highly precision-based, or whether or not it is, you have a restricted workspace. If you're looking, for instance, at a mechanic, you're working in an engine, you're not going to be able to get necessarily a power tool in there, whereas, a manual wrench is much smaller, no cords, no restriction, they're going to be able to have access quite a bit. Someone's just asked here if we will be sending the slides out and to the participants after the webinar. We generally don't send the slides out. No, we'll just have the recording available to you. So you'll be able to go on to our website or our YouTube channel, and you'll be able to get access to that. Another reason why you would choose a manual tool over a power tool would be so that because you have no access. We don't want to be having trip hazards of cords and, outlets out on the floor of our organization. So it's really not conducive to introducing, or maybe we're a field worker and we're working out, outside and don't have that kind of accessibility. Where we really do want to start looking at power tools would be any time where we have high repetition, high frequency. Something where you're going to be doing this again and again and again and again. It's not just going to be a 1 or 2 times a day. It's, every 30 seconds. So those types of things, obviously, where they're going to wear us out as a human much faster. And if we can put a power tool on that, then that's going to allow the muscular activity to be lower and still maintain the function of the task. Any high force, whether that be a high grip force, a torque force, a striking force, sometimes we can use power tools to minimize the impact on our bodies that way. And quality, our consistency. If we are having high force and high frequency in the task that we are trying to introduce a tool to, and we have a quality parameter that we need to make sure, that that bolt is tightened to a certain torque, then power tools are going to be able to tell you, you're actually going to be able to measure that tool has been torqued to a certain degree, and you're going to be able to do that one time, you're going to be able to do that, 1,000 times. And you're not going to have muscular fatigue and poor grip or, slippage kind of coming in there that's going to be compromising the quality of your product. All right. Okay, so your function of your tool. Some of these may seem very straightforward, but, for instance, the first question, is the tool making the job easier? So if we have something that we need to strike into, whether it be a piece of wood or a piece of metal, using a sledgehammer to break something versus a ball-peen hammer, obviously the sledgehammer is the right option to choose. However, that scenario is fairly black and white, and often we'll get them where they're not that black and white. So really, you know, we've already addressed that we need a striking tool. We know that we need a hammer, but what hammer? And making sure that that hammer is really going to be the right selection, the right size, it's not going to be overkill, it's not going to be underkill, because all of those things can help slow down the process and impact the body. We're also wanting, obviously, to reduce the manual effort. If we could do it with our hands, we would, but we're wanting to try and make sure that we're not actually adding any additional force or repetition or any ergonomic hazards, really, that come into using the tool. The idea of the tool is actually to lessen the muscular activity and the workload on the operator, but our tool choices can sometimes do the opposite of that. So one of the examples would be, you know, a pair of pliers where your hands are actually having to close and then kind of work inside to open, close. You're doing double the activity you would have to then, let's say, on a spring-loaded option, which we're going to, you know, it'll allow you to close with a little bit of control, but it's going to self-open and not require that activity or frequency to be increased. Ideally, we want it to increase the speed of the task. At the end of the day, for the most part, our organizations are on some kind of production or schedule-based system where we do need to finish a job in a certain amount of time. If a tool can help maintain that production or even improve it, that's kind of where ergonomics really starts to shine, where we can say, oh, you know, we're not using the right tool, let's introduce this tool. Anytime where you're going to be able to improve your productivity but decrease the injury potential on the operator, you know that's going to be a win. You know that's going to be a surefire bet for any kind of ergonomic change. So, you know, a good example of that would be using an automatic sander versus a manual, you know, sanding paper or sanding block. So ideally, we want it to increase the speed of the task, and we want it to improve comfort. There's no point in us trying to do all this if we're going to be increasing our injuries. We're going to have people going off. We're going to have to be retraining others. That in its own self is going to slow down the process and stop our production increases from happening. So making sure that rather than wait for someone to start complaining or injuries to start coming in, that selection process is built in when you start picking your tools. So rather than your hard metal grip, looking at a padded grip, making sure that some of the features that we're going to be talking about in just a second are already there. And that could be a matter of just looking at a spec sheet for a tool, taking 3 seconds and using a tape measure to measure the tool, making sure that it's really going to fit the process, fit the operator, and reduce your injuries. When we look in at work surfaces, this is some of the idea that we want to look at. So both of these tools on the side here on the peripheral of the posture illustration do the same function. They're all drill type tools to kind of screw something in or drill a hole. So they're doing exactly the same function, but one is going to be good for one situation and one is going to be good for the other. So whenever we're looking at anything downward forced, we know we want to get out of that pistol grip on the right. We know we want a straight handle, something that's going to be able to keep our wrist straight and in line, similar to the picture that we see on the top here. So you can see that the hand is in a good position, the wrist is in line with the hand, and we have a really nice, neutral, stress-free position for the hand and wrist. In this situation where we're working on a horizontal surface and you're using the pistol grip, you're going to start seeing images similar to the poor wrist function, where you're going to have the wrist bent down. You're also going to have, this tool is fairly heavy on the top end, which serves its function as a drill, but now you're going to have not just the awkward posture of holding a pistol grip tool in a downward angle, but you're going to have the force of that tool and the weight of that tool pulling on those muscles in the forearm as well. And it's just not a good match. And exact same thing happens when you start to switch the surfaces. If you're looking at a vertical surface, whether you have a panel in front of you or it's a wall or a machine that you're working on a vertical surface, either way, we start to see that flip. You start using a straight handle grip on a vertical surface, you're going to start getting those awkward, horrible postures on the bottom, and you're going to start seeing an improvement if you're able to use a pistol grip. So that's kind of your first one. If you're working horizontally, you need as straight a handle as possible so that you're able to get that image kind of on the top. And if you are working on a vertical surface, you're then going to want to switch to more of an angled or pistol grip tool so that it's doing the bending for you. Your wrist isn't. And your working height. This is one where I think we see the most. We see that the objects may be being considered or not. We maybe even see that the height of the workstation is being adjusted based on whether or not the work is precision. So, we go into a lot of labs and we'll see that the work surface is elevated more so than, let's say, a manufacturing floor. That's perfectly ergonomic. That we definitely want to see. Why? Because we're wanting to get our eyes closer to that precision work so that we're not bending forward trying to get that visual acuity component of the job function, of the job task embedded. So we're going to raise the work surface, but in doing that, we know we are losing our heavy hitting muscle groups. We're losing our lower back, we're losing our, just our bigger muscles. So we're going to be now focusing on forearms, shoulders. So those tools that you're using, if you're doing precision work, there's a reason they're small. Not only is it because you're doing something fine and fiddly that you're having to raise the work surface to, but it also aids in the fact that you're using smaller muscle groups to operate those tools. Vice versa. The heavier the work, the lower the work surface. But one thing we see that's being eliminated out of this design process is actually taking into consideration the length and size of the tool. So one of the companies I had been working with, and this goes back a few years, but they had obviously taken into consideration the object. They had designed their conveyor so that it was actually quite a bit lower than elbow height, so that the object that they were, the part that they were manufacturing was actually going to be at elbow height, which was great. You walked in and you had this massive part on a conveyor that looked low. It looked ridiculous, but when you saw the operator walk up to it, everyone looked to be that they were going to be neutral and it was all going to be great. Until you realize that every single thing that it gets attached to this part is torqued by a power tool or a pneumatic tool. And all of those tools were positioned by a suspension that was hanging above this lovely design that they've done. So in effect, what we found was the part actually wasn't the working height we were trying to adjust to. It was the tool that we needed to actually adjust to. So everything actually even needs to go lower, and the tools needed to be hung lower so that our postures weren't, kind of up around our head level and constantly pulling down from there. And even when we pulled it down, the top of the part was still at, shoulder height for most of our smaller individuals. So we need to not only consider how heavy is the work, we then need to consider the part that we're actually using on that surface. We need to essentially subtract the height of the part, and then you also need to consider the length of the tool. If the length of the tool is going to increase your arm or upper body posture, you don't have a great ergonomic design. So you need to really work on those kind of functions and dimensions to make sure that everything is going to be aligning as best as possible. As I mentioned earlier, your work surface. Does your work surface need to have a grip? Does it need to have kind of air balls or roller balls so you're able to function and move those? And if that increases the height as well and tool use is being used, you need to make sure that we're lowering things down accordingly. Okay? So the working heights, the ones that we have here, are kind of just standard, but obviously you can see they don't necessarily take into consideration your part length, nor does it take into consideration your tool length. So those are two things that you need to add into your design process to make sure that our workstation design and our surface heights are appropriate. Okay, so when we start getting into our guidelines, our first guideline is talking about weight. So when we're looking at weight, we have our one-handed tools. We generally want them to be below 3 pounds. Two-handed tools, I don't have that finished there, so I will make sure that gets changed. Our two-handed tools, we want to have a limit weight to about 5 pounds. Anything above 5 pounds, if it's being used frequently, we may want to look at some kind of suspension or counterbalance to that. And our precision tools should be weighing less than about a pound. So really, really light, you know, weights for those types of things. And then we're going to be spending quite a bit of time actually on the handle design, because really that is the interface that we're in contact with. That's what's going to be causing, you know, a lot of the adverse effects that we may be seeing in some of our injuries that are related to tool use. So our handle surface, what is it being made out of? Is it going to be aiding or hindering our grip? So you can see, you know, is the handle angled? If you're working on a horizontal surface and you need grip, then your angle of the tool, even though it may not be one that is normally angled. So you can see here we have a pair of pliers here. Normally, if you go into Home Depot, you're not going to see that set of pliers probably on the wall. That's a specialized tool because you're doing a specialized task. So making sure that the function of the tool or the angle of the tool handle is going to aid in the surface that you're working on, whether it's a vertical, whether it's a horizontal, whether you need to get around something. One of the misconceptions is the finger grips, the ridges that we kind of mold in, or manufacturers mold into our tools. We are kind of the belief that that is a good thing. However, if you consider the size of your hand and the size of your fingers, and let's say the size of someone who's smaller or larger than yourself, you can quickly see that my fingers maybe aren't necessarily going to fall into those ridges comfortably as maybe, let's say, my husband's or a coworker's or someone who's larger or smaller. So the last thing I want is either for me to be compromising my comfortable or strongest grip because I'm splaying my fingers to make sure that they're accommodating into these ridges, or even worse, I'm not accommodating my grip, and now I'm having these peaks kind of digging into the flesh of my hand and causing kind of almost acute trauma in that sense. So the ridges for our fingers, we really don't want those. We want really a soft, sculpted, a contoured hand tool, such as the picture on the right on that side. You know, something that's going to, you're going to feel the contact in the palm because that's going to allow you to have a power grip, and that's going to be your strongest grip. And you're going to be able to have a good kind of grip purchase, so to speak, on that tool, and it's not going to slip, it's not going to slide, and you're going to be able to exert the right amount of force rather than overcompensating on force because the tool's not really fitting the hand. Usually what we'll find is if a tool isn't fitting properly, we'll often exert more force and add awkward postures in to accommodate for that. So if a tool is too small for our hand, we're going to squeeze harder on that tool because we want to make sure that we are holding it and it's going to do what we want it to do without damaging either the part or the function of the tool. So looking at something that's going to make sure that it's fitting is really important. Your handle length is really important as well. You know, carpal tunnel has definitely been an injury that I think we've all kind of gone through, not personally, but in the industry that we're in and as health and safety specialists. Carpal tunnel is one that kind of came out on strong force when I started in the industry, and it's one we definitely want to avoid. So looking at your handle length, making sure that this tool is not ending in the palm of your hand. If you're looking at where your median nerve kind of goes through and connects at the base of your palm, this tool is hitting exactly that. So any force, any squeeze that that person's going to give is just going to push that end of the tool directly onto that nerve. And if that is, again, a task that's being done repeatedly, day in, day out, then it stands to reason that we are going to start seeing some breakdown and some soreness and some dysfunction with that, you know, median nerve in the hand itself. So we really want to make sure that we're looking at a tool handle that's at least 4 to 6 inches long. If you know that the individual you have is, you know, has exceptionally large hands, you may want to just be a little proactive and actually take a tape measure and find what the widest part of that individual's hand is and make sure that your tool length handle is longer than that. The general rule of thumb is if you're wearing gloves, gloves generally aren't going to help your situation if you have tool use. Gloves are going to desensitize the hand, potentially increase the grip strength, but rule of thumb is if you are wearing gloves, you're going to want to increase your handle length by about half an inch. So we're now looking at 4.5 to 6.5 inches long. Okay. Our span, so as we're talking about manual tools, for our double-handled tools, we're looking for an open grip span of about 3.5 inches, and closed it should be about 2 inches. So again, any less than 2 inches, we're going to see increases in the tendon tension, in the muscle force in the hand, as well. Anything more than that 3.5, you're going to start seeing finger stretch and just an inability to hold or exert any kind of force requirements on that tool. So trying to keep your tool spans in between the 2 and the 3.5 inches between open and closed is really going to aid not just the function of the tool, but it's going to reduce the amount of muscle activity and tendon stretch that you're experiencing at the hand and forearm. For our single-handled tools, we usually like to see our handle diameters to be about 1.25 to 2 inches in diameter. You go around and you start measuring some of the tools that are out there, and you'll see there's some that have really, really thin handles that don't even come close to matching this, and there's some that have way, way larger handles. We'll talk about in kind of the latter part of this of options you can do to kind of mitigate some of the handle diameters. There's some relatively easy, effective solutions that allow you to really customize your tools, and we'll talk about that when we get there. But as far as a base, 1.25 to 2 inches is what your handle diameter should be. For your precision tasks, we're now looking at a closed grip span of 1 inch and an open grip span of 2 inches. We're now we're not using the whole hand in these tasks. We're now using finger movements mostly, so we're not having to try and compress the whole hand to get a closed grip. We're just using our fingers, but anything, again, more than that, you're going to start seeing a stretch in the tendons in the back of the hand. And our diameters obviously are much smaller too, because we're no longer using a power grip, we're using a pinch grip. So for our precision type tasks, we're going to start seeing our diameters go from about 1/4 to about 1/2 inch in diameter, so that our fingers aren't gripping at a wide angle, because we're not really able to do that well. As soon as you start to, how you're able to pinch a piece of paper and how much you're able to pinch a ball, a tennis ball, is going to be much, much less, because you're just not able to get that contact, that closed finger pinch. So 1/4 to 1/2 inch in diameter, 1 to 2 inches in span. Vibration is one that we definitely want to talk about. This is limits that are generated mostly for power tools. So making sure that we are looking at, hertz that are going to be acceptable to the body. So we see less than 2 hertz of acceleration of 3 to 4 grams are intolerable. 4 to 14 hertz of 1 to 2 to 3.2 grams are intolerable. So depending on your size or the weight of your part and the frequency it's going to be causing, it really impacts the body negatively. Vibration is definitely one of those ergonomic hazards. It may not be one you see in every job, but if you have power tool use, it is going to be one that you're looking at. You're going to be looking at your hand-arm vibration limits, and you're wanting to make sure that those are as low as possible, so that you're not getting kind of frequencies that are going to be working against the frequencies of muscles that are trying to hold them. Selecting pneumatic tools that do not allow any kind of exhaust or air to vent onto the hand or skin, so that we're not kind of increasing any kind of the discomfort or to the hand or grip, is important too. Generally speaking, if we're having vibration tools, that's something we may want to monitor. As tools wear, vibrations will increase. So you may buy a tool that has a really good vibration, but you'll want to monitor that to make sure that as it ages, it's not going to be increasing some of those vibrations that you worked really hard to try and make sure we're going to be within guidelines and not going to be negatively impacting your employees. Okay, so when we're looking at some of our solutions, we really want to make sure, I think a lot of times our clients will kind of get almost blocked by the fact that what they see is what they get. you feel like your all options are only the ones that are available to you in the catalog or in the storefront. And that's not necessarily the case. If our tools, if we're able to buy them, following the tool guidelines that we just talked about, making sure that the diameter is good, that the tool length is good, that the span is going to be appropriate, then that's check one. But then we need to start looking at some of those other issues that really kind of go into the function of the job and the comfort of the user. So is the materials going to be soft? Are we going to be able to not create some of those contact stresses in the palm of the hand, specifically if we know that there's going to be high torquing, because in high torque comes high grip force. So those operators are going to be squeezing that handle, really digging it into the palms of their hand, and if it's a hard material or a rigid material, then we're not going to have a match, ergonomically speaking. So making sure the handle grip is softer material. Angled handles, and going back to the softer material, I have here, this is actually tennis grip tape. And this is kind of one of those solutions that I was mentioning earlier when I said about the diameter. Tennis grip is an amazing thing to have in your toolbox at any kind of workplace where you do have tools or things that people are handling. Not only does it add that soft material, but it's adjustable. So if I do have larger hands and I do want a larger diameter, you don't need to go get a new tool. You just need to put an extra layer of tennis grip tape on. It is really low cost. So, having a bunch of rolls lying around your office or in the tool room, that shouldn't be a huge expenditure. It's a great tool. As it starts to wear, you can take it off, add new, rather than again, oh, this tool is all broken down, we need to go get a new one. It's a soft grip tool. It is going to wear. It doesn't mean that the function of the tool, the actual part that's doing the job, is needing to be replaced. So your tennis grip, it's a great way, adding that soft material, allowing you to adjust the diameter of the tools. If you find right now that your tools are too narrow, rather than saying, okay, we're scrapping all our tools, going out and getting some tennis grip tape might save you actually a couple years before you have to retire those tools and replace them. So definitely I'm a big proponent of the tennis wrap. Angled tools. And again, there's a plethora of tools out there that you can get angled. I will say that is one area where price points may start going up, because that is definitely an ergonomic marketed field where they're going to see that this is being a specialized tool. But if you have an organization where your fabrication or your tool room guys are really great, we have done a number of wonderful things to tools to add not only angled tools but adjustability in your tools. So as you go on to the power side, adjustability. I worked with one company where we had a gentleman, he had to use a grinder, and usually the grinders come at either just a straight handle, or you may get one handle right off the edge. However, how they had to use it, which was the inside of a tube essentially, caused all kinds of awkward wrist postures, and it just was not very pretty. What we ended up doing was creating a collar around that tool and having ball jointed handles so that he could adjust those handles as he needed to, depending on the surface that he was working on. So just because the tool doesn't have it or you can't find it right off does not mean that it can't be created. It really comes kind of that out-of-the-box thinking that we all know and love about ergonomics, and we definitely want to start seeing some of that innovation and kind of thoughtful thinking come out. So if we can't buy an angled handled tool, even though that's what the task really would require in order to allow our operators to work neutrally with less force, then maybe we can create it ourselves. Definitely looking at tools that are light. So you're talking at 3 pounds. 3 pounds is not bad, but even from my experience, a 3-pound tool, depending on if it's being used constantly throughout the day, is still going to be a relatively heavy weight. When we start looking at some of our other guidelines that we have out there, so for instance, if you're doing an ergonomic assessment using the RULA, the Rapid Upper Limb Assessment, they're looking at anything less than 4. As soon as you get to a 4-pound tool, you're scoring that as a risk. So those are kind of two parameters that really kind of speak to each other relatively closely anyways, and making sure that the tool, although it's, you still want it to be durable enough to do the task, but you want to make sure it's not, going to be heavier than a tool that you could buy that's one over but just made of a lighter material. And really looking at not just longer handles on your tools to make sure that they're not being embedded into the palm of the hand. We've already discussed that and why that's not good and why we want to have that 4.5 to 6.5 or 4 to 6.5 inches depending on glove use handle length. But if the tool requires high torque, getting a longer tool, I know throughout my years with my various companies that I've worked with, the use of kind of push sliding a tube or I guess a tube, essentially, over kind of a wrench to increase the length of the tool arm. There's some health and safety risks in doing that. So if you know that this is something you're constantly going to have to do, a longer handled tool is going to still give you the same function without the health and safety risks, but you're really going to be able to reduce the forces that the operator is going to have to exert if you have a longer handled torque ability on the tool. So that's something else to consider. Again, if that can be done fabricated in-house, and that may be an option, but just looking at if these pipe clamps or these CIP panels that we have are going to need to be torqued to a certain length. We don't want a short-handled tool for that. We want something longer that we're going to be able to tighten easily, as well as untighten, because that's often the other issue. Someone comes in on the night shift, they're really strong, they've got this so tight that it doesn't seem possible to get off. A long-handled tool may help make that a little bit more consistent and also allow someone who's not as strong to still allow them to undo or tighten the part or panel or whatever it is you're trying to use the tool for. Moving on to your power tools, we start looking again, as we said earlier, definitely on your vibration. Oh, sorry, 1 second here, we just have a question. Yeah, sorry, the question was just asking if tennis grip is easy to find. You can find tennis grip from places like, your Sports Check definitely will have it. I have seen it, not as often, in places like Walmart. You can get it online really, really easily. It's very readily available and very easy to find. So, as I said, it's just something to put in your tool. I've used it on even pens. So people that have they have to do a lot of writing, but the companies only provide, the really narrow Bic pens. The person can then just wrap up a little bit of tennis grip and put a softer grip on their pen, as well as increase the diameter so they're not getting that really tight pinch grip that's causing a lot of force. So anyway, I really can't talk enough about tennis grip, but as you can see, I'm a big proponent of it. So, but it's really readily available, easy to find, and can do a multitude of things for you. So back onto the vibration dampening, oddly enough, your tennis grip is a vibration dampening material. That's actually what part of the purpose it serves on a tennis racket, so it's good that way. But looking at not just your dampening handles, that's sometimes where we may look at vibration dampening gloves, but if you know that there's going to be a torque or a kickback, that we are setting those tools up to have that absorbed by more mechanical structure rather than having that vibration or kickback absorbed by the body. We don't want to really get into the negative aspects of vibration when it comes to the body. It really sometimes can take very long periods of time to recover from the ailments that come from vibration exposure for hand arm. So making sure that that vibration dampening is happening, whether it be through an absorption surface or whether that be through a mechanical aid that's actually taking the torque or the kickback off the body. Definitely look at suspending your tools. We're talking, 3 pounds. We definitely have tools out there. You look at your grinders, even your drills. It's hard pressed to get a tool that's under 3 pounds that's a power tool. So looking at either putting them on a suspension arm or some kind of like a monitor arm type thing, but rather than it holding your monitor, it's going to hold your tool. Still allowed multiple bends in it, so you're going to be able to use it in a multitude of ways, but getting that tool weight held by something other than the human hand is going to allow a reduction in force and activity in the body. Therefore, it's going to correlate to a reduction of injury in the workplace. Talked about adjustability, looking at those tools that offer different uses, different adjustments in them. Some of them are a function of the tool, some of them are added features. I know there's several brands of drills and that type of thing out there, or even screwdrivers, where they will have a bit of an option to angle the handle. So, and angle the handle anywhere from being a straight angle to 90 degrees and anywhere in between that. So it really does, those kinds of tools, if they're not required in really, really high forceful situations, whether that be a manual tool or a power tool, they can offer a lot more usability and function within a workplace where we know it's not necessarily going to be used in the same way every time. So we're getting more use and more bang for our buck from the tools we have because we picked a tool that has adjustability built in, rather than buying 7 tools that have 7 different angles. Buy one tool that offers an adjustable angled tool or handle. Tools that pulse will help with that vibration component, so they're going to help with minimizing not only the torque kickback, but the continuous vibration exposure to the hand and arm. Auto shutoffs, they'll automatically shut off. They will also help with the vibration dampening and help with just kind of either awkward postures to trying to shut it off, or that immediate kind of kickback that we get when our power tool shuts off automatically. The auto shutoffs usually have a kind of a slow down phase so that it's a bit more gradual, a little bit less impactful. We talked about the soft grips on the manual tools. The same thing applies for your power tools. You want to make sure that that's being considered and that your tools are balanced correctly. Oddly enough, this is again specifically with my power tools. As soon as you add a motor, the balance of the tool can sometimes function really poorly. I've seen drills that basically, if you were to just kind of pivot it on your finger and see which way it's going to spin, it'll spin actually away from the drill point, so it'll spin back towards you because all the weight's in the back of the handle and there's been no counterbalancing to the front. So there's a reason our tools are designed the way they are, and it's to serve a function or a purpose. If we're having to fight to just angle the tool, let alone hold the tool in place and make sure it's making good contact with the screw or the part or whatever it is we're trying to torque or move, then you've just added an increased activity or physical demand to that job that does not need to be there, because there is a tool out there that does have better balance. So just something to consider. Again, talk to your maintenance guys. They will usually have a really good handle of what a good tool is versus a bad tool. And if you're new to it, even just, next time you're in at Home Depot or Lowe's, go to the tool section, pick a few up, and you'll really get an idea of how badly balanced some of these tools are and how they are actually working against what we're wanting the tool to do. And so therefore, to get the tool to do what you want it to do, the body's going to have to do that activity. And that's totally defeats the purpose of a power tool. So balance is actually a key one. It probably should have been up higher. So definitely keep an eye out for that. Sorry, I just have another question here. Oh, no problem on someone was just thanking me for the tennis grip suggestion. Okay, so the other thing I want you all to consider is something that we definitely come across when we're doing our ergonomic assessments is we have the right tool, we have the right surface. A lot of thought, a lot of consideration has gone into making sure that the task and the workstation and the function is all can really be called ergonomic in the truest sense of the word, and then we just walk away. We did our work, we put our effort in, we made sure all the checks were done in our checklists, and we came up with a really, really great workstation and task and function, and everything's working well. And then we think that's the end of the day. Tool condition drastically affects not only the quality of your product, but it also affects the safety for our employees. You start getting, if you have a blade you're using some kind of saw or chipping blade or grinder disc, and it's got a chip in it, the ability for that to crack and fly and become a projectile is huge. So definitely, poor tool condition is going to compromise your safety. It's going to start vibrating more, which I've tried to, without going into a huge discussion on vibration. Vibration is bad, really bad, and if you are increasing it because the tool is just getting old and things are just needing to be tightened or fixed or lubricated even, easy fixes. But if we're not doing them, that increased vibration, that increased workload to kind of compensate for that, or just the exposure to it, is going to start not only decreasing the employee's ability to do the job within the parameters that we've set out, but we're really increasing their chance of injury. We may find that it increases our repetition, so we start seeing decreases in efficiency. You, for instance, if your job is to screw in a screw, and this is really where I'm going to show my non-tool knowledge, the square head screwdriver. If you're using one of those and all of a sudden that square, those corners really aren't there, they're really more just circles, then it doesn't matter how hard you push on that screw or how frequently you rotate that handle, that screw isn't going to be going in because it's not going to be catching anything. So making sure that even, let's say, if you're looking for a screwdriver, if you have an option of which screwdriver you're using or which nail or screw head you're requiring, you may want to pick ones that don't wear out. That square wears quickly. Those corners wear with use, and as soon as they start to kind of strip down, then we're not going to be able to get the job done. We're going to take multiple tries. We're going to start seeing compromises in our quality because it's not going to be screwed in enough, just things like that. So one great way to do that is create a pre-use checklist, just something that's there that, whether you stick it up at the workstation and it's, 4 points, 5 points, it's going to just have someone look at the key points of that tool, whether it be a grinding blade, whether it be the screw head, whether it be, the handle of the hammer or the cord. It really comes in a lot with our safety program, so we often will encourage our clients to use them if we're doing kind of your job hazard analysis and that type of thing. But because of the negative impact they have on the ergonomic side, it's a good thing to just do, not just for the safety side, but to make sure that the body is not making those, adding those things on our body rather than adding it to the tool. So at that point, as soon as we start getting those handed in, whether it be in maintenance or we have it being retired so that we're getting a new tool at that point. So your tool condition, regardless of how well you've bought it, all the ergonomic considerations, the guidelines you've taken in, the tennis grip you've wrapped around it, the handle length, if you just let it get worn and worn and worn, it's still going to potentially be a problem for you. So make sure you have some kind of program in place that's going to help with that. Okay, so just kind of as a summary, your next steps may be, identify the jobs that you have that are actually using tools. That's a good indicator to kind of keep an eye on that maintenance program. If you don't know where the tools are in your organization, it's going to be hard for you to track them and figure out if they're in good condition. Making sure you're using that kind of 4-step formula. What's the job? What are we trying to do with the tools that we're using? Can we, in good faith, say that they're been chosen because of ergonomic parameters, or we just chose it because, this is what was here when we got here, or it was the first one I put my hands on the catalog or in the tool shop. If you are in a position where you're looking at buying new tools, using some kind of hand tool checklist, something that's going to remind you of some of those guidelines and parameters and really kind of challenge you to make sure that your choices are not just speedy, quick, we need a new tool fast, but they're educated choices that have ergonomics in mind. Developing your maintenance program, as I suggested, and always be on the lookout for new innovations. It is astounding. Even if you just Google, ergonomic screwdrivers into your Google images and just look at some of the pictures that come up. Some of them may be nothing, but every now and then you'll come across something and you'll be like, oh my gosh, that is amazing. That's what we need. That's what we've been looking for. That's what will solve us all our problems. So, and if you're not seeing it, but you can think of it and you have a handy fabrication department or someone who knows how to build things, pitch it and see if you can start maybe making some of your own tools, specifically if you know, it's going to be very specific to the part or tool or function that you're doing at your organization. But the greatest thing about ergonomics is the innovation, so let's kind of keep that on the forefront. Okay, does anybody have any questions? I know we've had a couple on the tennis grip, and the guidelines are kind of there really just as part of that checklist that you may want to put together, and then we can look at developing that kind of program where we're going to not just know that we bought the right tool, but when do we need to maintenance it, when do we need to retire it. Quiet group so far. That's okay. Well, I hope you guys all enjoyed the webinar. And if you have any questions or you want to reach out to us, please give me a call. I'm a phone call or email away. I'd be happy to answer anything you have or help you with any of the ergonomic woes that you may be experiencing, whether they be tool related or not. Jennifer McGillis, there's some of our references which will show up in the video if you want to look at some of the other ones. So one of them is the Canadian Prevention Board. They actually have a NIOSH document out there that kind of goes through a lot of the guidelines for you. So that may be one that you want to download. If you're interested, you can just email me and I can email it to you because I have it on my resources. So, but Jennifer, not quite sure what's going on there. Jennifer McGillis will be doing next month's webinar, and it's going to be a really great one on job rotation and is it an effective solution to reducing injuries. There are lots of reasons to do job rotations. They may be for monotony, they may be for cross-training, but if you're looking at one that's going to reduce injuries, there's a bit of science to that, and if you are able to do it, that's great, but there's some challenges that come with that. So if you're looking at doing a rotation, if you have a rotation currently, definitely sign in and register. Even if you're not able to attend, if you've registered, at least you'll get access to the recording and you can view it at any time or show it to your joint health and safety committees or whomever you would like. I appreciate your time, and again, if you need to reach us, you know where to find us, and I hope you have a great day. Take care. So you know, I will be on shortly just in case any questions do come up.